ago. And the period was 11.6 hours. So 11.6, 1, 2, 3, 4, 23.2, 1, 2, 3, 4, 34.8. And our wave then looks something like this. It started at low, midline, top, midline, low, midline, top, midline, low, midline, top, midline, low, midline. And so the wave over the course of time, or the tide, I should say, not the wave. Suppose it's a sine wave or a cosine wave. Looks something like that. Just the in there a little bit, but you get the idea. And that's where we were at. Okay, what information here did we have? We had amplitude was 3.75. We had figured that out. Okay. We had that the equilibrium, or the vertical shift, in other words, was 0.15. Had we written down what the period was? 11.6 hours. Right. And did we calculate what K was based on that? Okay. So based on 11.6 hours, we said 11.6 was 2 pi over K. So 11.6 K equals 2 pi. So K equals 2 pi over 11.6. And by typing 2 over 11.6 into our calculator and converting to a fraction, we got that to simplify to 5 pi over 29, so we didn't have any decimals inside of our fraction. All right. Is that where we were at? We didn't have any other information, right? All right. Now, the only transformation we haven't described here is a horizontal shift. But if we're smart about this, we can deal with this so that it doesn't have a horizontal shift. What type of function would I want to use if I want this to be my starting point? Cosine. And specifically, what type of cosine function? A negative cosine function, right? Cosine starts at the top typically. This one's starting at the bottom. So if I have a cosine function with a negative amplitude, I don't have to worry about my horizontal shift at all. Okay? And a cosine function is a sinusoidal function. Okay? It doesn't have to be sine simply because we're talking sinusoidal. So our equation then becomes y equals negative something cosine of something t plus or minus something. And if you want, you can put the parenthesis there. So what goes in what blank here? We basically have all three values. We just need to figure out which one goes where. Where does the 3.75 go? In front of cosine, right? The amplitude is the coefficient on the cosine. So negative 3.75 cosine of, all right, where does the equilibrium, the vertical shift, go? After the parenthesis, and it's added to it, so plus 0.15. And then that leaves the last blank to be what? $11.6. The value of K that we get based on an 11.6 hour period. So this will be 5 pi over 29. This value right here. All right. Questions there? Okay. Last question before we go to our next example. Part 3. What is the height of the tide after 12 hours, or at the 12th hour. Was the height of the tide 12 hours into our model? We could try to approximate it by looking at 12 here on the x-axis, right? Because t is my hours. And let's see, the wave is below the x-axis at that point. So we could come down to where 12 hours to where our wave is, and then we could approximate it by determining what y value that is. Any guesses on what y value that is? 3.5, 3.4, 3.58. Okay. How about if I go 3.45 meters? Approximately. Is there a way I can do this more specifically? Plug in 12 for t, right? T here equals 12. And so let's plug 12 in for t in the equation. Y equals negative 3.75 cosine of the quantity 5 pi over 29 times 12 plus 0.15. Oops, no parenthesis there at the 0.15. Does my mode matter? Okay, which mode should I be in? Radians. Mode. I'm in degrees right now. That would be problematic. Cosine of 5 pi divided by 29 times 12 plus 0.15. Negative 3.51. Okay, so our graph is pretty accurate. And it would be in terms of meters. Our height was measured in as a number of meters above or below. Above or below what? Sea level. So this would be negative 3.51 meters above sea level, which sounds a little bit silly because it's not above sea level. It's a negative number of meters above sea level. You could, if you wanted, you could say positive 3.51 meters below sea level. Just please do not answer with negative 3.51 meters below sea level, because a negative distance below would actually be above. So either leave the negative in there and measure it in terms of meters above sea level, or allow the negative to change whether we're above or below. Questions there? Okay. I have for you a super exciting problem. I heard that. Okay, so maybe you don't like it as much as I do. Write an equation to model the amount of sunlight, or let's say it this way, to model the amount of time from sunrise to sunset for any given day in Rockford. Right? So how much time elapses from sunrise to sunset for any given day in Rockford? First question should probably be, is this periodic? Does the amount of time that we get sunlight vary throughout the course of the year? Yes, it does. Right? We're finally coming out of winter. The day is getting longer. I tried to explain to my 6-year-old why we have daylight savings time and why we set the clock ahead an hour and why she still had to go to bed at 7, even though it was really 6. It has to do with farming. I don't know exactly. In the evenings. More evening daylight. All right. Is it periodic? That's probably the next question we should ask. Does the amount of daylight fluctuate periodically? Yes, it does. On what period? Not 24 hours. Go with what? 12 what? 12 hours? No. Today, we're going to get about 700 minutes of sunlight. 700 hours of sunlight. No, 700 minutes of sunlight. When's the next time that we will get about 700 minutes of sunlight?
Tomorrow. Said about
365 days from now. Okay? So the period here is 12 months, or more specifically for our purposes, we're talking about any given day, so we want to write this in terms of days. 365 days. It's really 365.24 days, but 365 will be close enough. Okay. Now, students of mine several years ago were nice enough to mine some data for you. Okay. I know, right? Well, nice. I made them, one of the two. Okay. How bored were they? Oh no, it was a requirement. It was part of their assignment. So I have here a couple of lists: the day of the year and the number of minutes of sunlight. Now they did it for a 3-year span. So like, I think this was 2009. So like this would have been December 31st, 2009. 7:30, that would be December 31st, 2010, and 10:95, that would be December 31st, 2011 then. So we're talking about a number of days since since January 1st, 2009. Okay? So that's why you see numbers bigger than 365 here. But here's the day of the year, and then the number of minutes of sunlight. You'll notice that on the last day of the year, we had about the same number of minutes of sunlight each day. Okay? And then this was like the middle of July or something like that. 270? No, sorry, this was like October or something. Okay? And for 3 consecutive years, and the number of minutes of sunlight. Okay? Now, that's not super important to you. I wanted you to see the data because I'm going to graph the data here. And let's see here. I want list day for X list, and I went list minutes for the Y list. And I'm going to change these to just the little dots. Okay, so now this is going to plot my days as my X list. My days will be along the X axis, and my minutes of sunlight will be along the Y axis. Okay, now let's talk about a reasonable window here. What would make sense for my number of days? For a minimum and for a maximum? Okay, 365 for a maximum. If I was going 1 year, right? Now my data actually goes out 3 years. So how about for a maximum we go like 365 times 3? Okay, and then I'm just going to add a couple of extra days on the end just so we've got a little bit of space. So we'll go out to 1,100 days. Okay, what would be a good minimum? 0? Good minimum? Okay. I'm going to go a little bit to the left of that just to give me a little space on the left. So I'm going to go from -10 to 1,100. And for my scale, I'll have it mark off every 30 days. That would be about every month or so then. Now, what you make your X scale is not a big deal. Okay, Y minimum, Y maximum. Let's see. The Y was the number of minutes of sunlight. What would be a reasonable minimum? 6 hours? Do you think we ever get less than 6 hours of sunlight? That would be like from 9 a.m. to 3 p.m. Okay? Or below the minimum? Oops. 6 times 60 would be 360. We'll start with that and see what happens. What about a y maximum?
700.
700? I think there were more than 700 there for days. Let's see. Do we get more than 12 hours of sunlight some days? Oh, yes, we do, because we get 12 hours of sunlight approximately 12 hours on the equinox. So how about 18 hours of sunlight? We probably don't ever get 18 hours of sunlight, but let's take that as our maximum. So 18 times 60, that would be the number of minutes. So we'll go from 360 to 1080. And let's go by 60s. That would be then marking off every hour. Okay. And here's the graph. Ooh, that looks pretty nice, actually. Okay. Now, some students were not so good at calculating the amount of time. Some students were not so good at calculating what day of the year they were working on. But for the most part, most of these points are right on. Now, does that look cyclical? Yes, it does. It should. Right? It should look like a sine function. So the question is, how do we write the equation of that sine or cosine function? Thank you. Well, what kind of stuff do we need to pull out here? What kind of information do we need to know? Amplitude. Okay. How would we find amplitude? We have the period already, right? So that's one step down. How would we determine the amplitude? From here? Okay, not quite. Okay, the minimum is going to end up being a little bit lower than that, right? If you look at kind of these points here, they're a little bit lower than this point here. Okay, but it would probably be good to know the minimum, wouldn't it? To know what this minimum value is. I'm guessing this person was probably off. Do we know the minimum? Or at least when the minimum occurs? That one day in December. Yeah, what do we call that? Winter solstice. I think so. What day is the winter solstice? December 21st. This year, anyway. Okay, and then the summer solstice, right? What day is the summer solstice?
Summer begins on the 20th of June and ends on the 21st of September.
20th of June. Okay, so June 20th and December 21st. Let's find out how many minutes of sunlight we had on those 2 days, shall we? We shall. All right. I'll put Siri away. We'll go to Google. Sunrise and sunset in Rockford. All right, I want to change the day here, or change the month. How about if we go to December? And we're just going to go sunrise, sunset, the first two columns here, not... Ooh, they give us the day length. That's cool. So we don't have to calculate it ourselves. This actually gives it to us. 9 hours, 5 minutes, 9 seconds. We'll just say 9 hours, 5 minutes. Okay? So, Zach, please remember 9 hours, 5 minutes. Okay? Or write it down. All right, June. And we want June 20th. I think it'll actually, let's see, here we go. June 20th. 15 hours, 16 minutes. Jordan, can you remember 15 hours, 16 minutes, please? Okay. All right, so December whatever, December 21st. It was what, Zach? 9 hours, 5 minutes. So the number of minutes would be 9 times 60 plus 5, right? 9 sets of 60 plus 5 extra. So that's going to be 545 minutes. There's my minimum. 545 minutes. Okay. Now, Jordan, the maximum was when? 15 hours, 16 minutes. So 15 sets of 60 plus 16 extra, okay, which is 916 minutes. That's my maximum. Okay, so this is about 916, somewhere up here, and this is approximately 545. Now, based on those two numbers, how do I find my amplitude? Okay, subtract them. That'll get me the distance between them, right? And divide that by 2. Because the amplitude is not from top to bottom, but from center to top or center to bottom. So we want to take the difference here, 916 minus 545, and we want to divide that by 2. 916 minus 545. Thank you. And then divide that by 2. 185 and a half. So essentially, from the spring equinox, which happens here shortly, the next several days, the next week sometime, to summer, we will gain 3 hours of sunlight. And since December 20th, pretty much since Christmas, we've gained 3 hours of sunlight or daylight.
8 p.m.
Okay. What else do we need to know? Period, amplitude, shifts. Okay, let's pick a shift. Vertical shift. The vertical shift is the equilibrium, right? Somewhere around here. How would we determine that value? Half the amplitude. No. It's going to have to be a number between 545 and 916, right? Subtract what? Oh, 371 or whatever. Well, 371 is not going to be in there, right? 371 is just this distance. It doesn't mean that it's the distance from 0. There are 3 ways we can do this based on what we already know. Do you know what this distance is?
Yes.
What is this distance? 185.5. So 545 plus 185.5. 545 plus 185.5. Okay, that's one way to do it. I'll give you the other ways here in a minute. 730 and a half. Okay. We could go from 916, we could subtract 185 and a half. Or we could average the maximum and the minimum. 916 plus 545 all divided by 2. As opposed to taking the difference and dividing by 2, taking the distance between them and dividing by 2, take their sum and divide by 2. That would give you the vertical shift. All right, what else do we need here? The value of k. All right, let's find the value of k. How do we, or what formula involves k? Formula for the period, yeah, 2 pi over k. Now, Ethan talked us through a shortcut to this, but if you don't recall that, then probably just want to go with it this way. Okay. What's the period? 365, right? We want t in terms of days. So 365 equals 2 pi over k. You want to cross multiply? 365 over 1. So 365k equals 2 pi. So k equals, this looks really gross, 2 pi over 365. All right. Anything else we need? Or having amplitude, vertical shift, and k is enough? Okay, we need to know which function it is. Sine or cosine, right? Those are the only options we have at this point. Negative cosine. Why negative cosine, Zach? Okay, so our wave starts at the bottom. Almost. Okay? I have no problem with using negative cosine, though. It might be the easiest thing to do here. Okay? I have no problem using negative cosine, because we are close to the bottom here. All right, so let's do that. Let's put, but we do need to deal with our horizontal shift. Unfortunately, okay, January 1st is 1, right? Would be the first day of the year, which means 0 is really December 31st. Yes? Unfortunately, December 31st is not the winter solstice, therefore it's not the minimum. The winter solstice is the minimum, which we said happens on December 21st. So let's see here. In terms of our horizontal shift, we want December 21st to be the horizontal shift. What day of the year is December 21st? What day of the year? If you were to number the days 1 through 365, right? 355? Let's see. I'm not above counting on my fingers. December 31st would be the 365th. So the 30th would be 64, 63, 62, 61, 60, 59, 58, 57, 56, 54. Oh, 55. Sorry, I skipped 54. How embarrassing. The 355th day of the year. So our horizontal shift here is 355. Or negative 10. That'd be one period from 355. All right, let's write our equation. U gross. Y equals, it's going to be a negative something cosine. It's going to look like that. I'll put a t in here where t represents, t equaling 1 would be January 1st. Go ahead, help me fill in the blanks here. 185.5 goes where? Okay, goes in front of the cosine. Negative 185.5 cosine of 2 pi over 365 times t. Now, we talked about the shortcut, right? Where we don't have to deal with finding the value of c by doing this. Right? We talked about that the other day. And then in this case, I can just input here the opposite of my horizontal shift. So I can write this as minus 355. Plus 730.5. Yeah, that looks gross. But it's done. Y equals negative 185.5 cosine of 2 pi divided by 365 times the quantity x minus 355, close parenthesis, plus 730.5. Everything look in order there? Waiting for me to hit graph. Jordan, you nervous? You're not nervous, you're confident in this, huh? You feel like it's totally messed up. That's a really ugly looking equation. Anybody nervous? Ashley nervous? This is not going to be right? No?
Sorry.
I know, that makes me nervous because, like, if we're wrong, then we have to go back and figure out what we did wrong. Yeah, we do. I don't know if I can do it. Okay, go ahead. Do the honors, Sweeney. Okay, wait. Oh. It should pass through there. Yeah? Yeah? We are so smart! High fives all around! High fives all around! Okay!
We got it right. I don't care.
That's awesome!
I feel like you didn't have any conflict.
Oh no, I was pretty confident it was right. But that's awesome! I know it's complicated. Really complicated. But we did it right! Hey? No. Your test question won't be nearly that hard. Okay? But actually, in August, had I told you we would be doing stuff like this, you would have been like, Miss Week, are you so crazy? Not like that. I mean, that's not how you talk. I know, but okay? You would have thought there's no way. Had I given you an equation like this and said we're going to be talking about things like this year, you'd been like, huh? Yeah, but hopefully not nearly as bad as you would have felt on August 31st or whatever. Yeah, does August have a 31st? Yes, it does. Okay. Well, yeah, we know kind of how these values affect the graph, right? It makes sense where this came from. Okay? Now, am I expecting that you can do this perfectly right now? No. But that's what we're going to take tomorrow for. We're going to spend one more day on this. I'm going to put you in groups, essentially. I'm going to have you get together with other people, and I'm going to have you work on a problem similar to this. It will not be this hard. Okay? But it'll be similar to this. There are questions in your homework somewhat like this. Okay? No, the homework's not due tomorrow. It's going to be due on, what is today, Wednesday? It's going to be due on Friday, because we're going to take one more day. Talk about sinusoidals. Okay. Questions there?